Hi, students in Algebra B. Happy Tuesday. I apologize that I am not in class today. So again, we are going to watch another video on graphing quadratics. This time we are going to learn about intercept form. So as you can see in front of you, you should have this packet. And so the video that you guys are going to be watching today is going to follow along with this material. So first off, we see a quadratic, and we know right away that this is in factored form, or sometimes we call it intercept form. Some of those key components to your quadratic are still the same. For example, is this function concave up or concave down? Well, if you notice, we don't see any negative at all in the function. So we're going to go ahead and label this parabola as concave up. Does this parabola have a vertical compression stretch, or is it neither? Well, in terms of when we distribute this later about standard form or just trying to figure out what our a value would be, x times x is x squared. We don't have any coefficient out in front, so our a value is 1. So therefore, there is no stretch or compression. If we see two factors such as this, x plus 5 and x minus 1, we can go ahead and find the x-intercepts of this function by factoring to solve. Now, in our case, it's already factored for us, so we can go ahead and substitute that y value in for 0 and say that 0 is equal to x plus 5 times the quantity x minus 1. Because both of those are being multiplied together, we can go ahead and set each of these factors equal to 0. We can subtract 5 from both sides. We get that x is equal to negative 5, and we get that x is equal to positive 1 when we add 1 to both sides. Now, because it's asking for x-intercepts, we know we want to write our final answer as negative 5, 0, and 1, 0. If you'd like, you can go ahead and plot those points right away. 1 right here, negative 5, 0, and 1 right here, 1, 0. Now, in order for us to find the equation of the axis of symmetry, we have two options. We can use the formula x equals the opposite of b over 2a, but in our case, we don't really think that that would work out well because our equation is not in standard form. So we do want to take both x-intercepts and we want to find the average of them, just like we were doing in yesterday's video. So we can take negative 5, add 1 to it, we get negative 4, and by taking the average, we can go ahead and divide by 2. So therefore, we get negative 2. Our axis of symmetry is where x is equal to negative 2. And we can go ahead, and I'm going to use a highlighter for this example. You can go ahead and put that dashed axis of symmetry in the line where x is equal to negative 2. Now, using that axis of symmetry, we can go ahead and find the vertex. The axis of symmetry, where x is equal to negative 2, is our x value. So we can go ahead and substitute that in wherever we see x in both factors. Negative 2 plus 5 is positive 3, and negative 2 minus 1 is negative 3. So therefore, y is equal to negative 9. So our vertex is negative 2, negative 9, which we can go ahead and plot right here. Negative 2, negative 9. And then our last and final step, which is our last question, is find the coordinates of the y-intercept. Well, typically our y-intercept is the c value in standard form. However, we don't have a c value here because our equation is given to us in factored form. So our y-intercept is always going to be the point 0, y. So really, where x is 0, what is y? So really, all we're going to be doing here is plugging in 0 for x, finding our y value, and that's our y-intercept. So again, y is equal to 0 plus 5 times 0 minus 1. 0 plus 5 is 5. 0 minus 1 is negative 1. So therefore, y is equal to negative 5. Our y-intercept is 0, comma, negative 5. And we can go ahead and plot that right here on our parabola. Now, yesterday we talked about this idea of mirroring points. Because your parabola is symmetrical, we notice our y-intercept is 2 units to the right away from the axis of symmetry. So exactly along that same y value, we could go 2 units to the left. And beautiful. Now we have another point to add, and we can go ahead and sketch in this parabola. And voila. And that is just a little warm up on sketching parabolas when our equation is already in factored form. So let's go ahead, let's turn the page. And if we take a look at this next page, it says use the quadratic functions below. We need to find the concavity and we need to find the x-intercepts. And really, we want to make sure that we see these connections. Our x-intercepts are going to be graphed. And so that way we can, one, plot those points and use that to just sketch if the parabola would be up or down. We really don't care so much about the vertex right now. It's just seeing that connection. If the parabola is concave up, if the parabola is concave down, that your solutions for x are also your x-intercepts. That is really what we care about here. So first off, notice there is no negative value at all in this equation. So our concavity is that this is concave up. Now, in order for us to find our x-intercepts, we do want to set the function equal to 0, and we do want to solve. Once we set them each equal to 0, we can add 3 to both sides. X is equal to 3. We can add 6 to both sides. X is equal to 6. And if we know our two solutions, remember, your solutions are your x-intercepts. So our two x-intercepts are 3, 0 and 6, 0. And really, we can just move right over to this graph. We can go ahead and plot 3, 0. We can go ahead and plot 6, 0. And then really, because it's concave up, all it's asking for is just a sketch. Notice we have 2 x-intercepts, nothing more, and that is it. All right, let's go ahead and let's look at the second example. Okay, notice right away, our second example, we see a negative out in front. That's going to tell us right away that our parabola is concave down. Now, in order for us to find our two x-intercepts, we do need to find our two solutions to the equation. So we can go ahead and substitute f of x with 0. We can say 0 is equal to negative times x times the quantity x minus 2. Now, remember what we said yesterday. Just because our parabola is concave up or concave down does not affect the solutions at all. In fact, if you keep the negative out in front of x, we would just be dividing by negative 1, and 0 divided by negative 1 is still just 0. If, excuse me, if we kept the negative 1 out in front, you can't set negative 1 equal to 0. So in the end, we're still just setting x equal to 0 and x minus 2 equal to 0. So now x is equal to 0. We're done. That's already isolated. That's awesome. But with x minus 2, we can go ahead and add 2 to both sides, and we get that x is equal to positive 2. So now our two x-intercepts are 0, 0, and 2, 0. Once again, we can go ahead, plot those 2 points, one right here, and because our parabola is concave down, we just do that. And like I said, we don't really care so much about the axis of symmetry, about the vertex. We're just trying to really hone in on the fact that your x-intercepts are your solutions. And your concavity really tells you if your parabola is going to be facing up or if your parabola is going to be opening down. Now, if we take a look at number 3, we have the equation x squared minus negative 4. Now, it's positive right away, so we know our concavity is concave up. However, there's a few different methods that we can use to solve for number 3. Go ahead, pause this YouTube video and actually pause it and go ahead and try to solve. Okay, welcome back. Hopefully, you know that if you set this equation equal to 0, x squared minus 4 is equal to 0, you could add 4 to both sides. We get that 4 is equal to x squared. We can go ahead and take the square root of both sides, and we get that x is equal to positive 2 and negative 2. X is equal to plus or minus 2. However, also, on the flip side, you could have factored this. 0 is equal to x squared minus 4. Well, what are two factors that multiply to negative 4 but add to 0? That is x plus 2 times x minus 2. You can go ahead, set each equal to 0. For this first one, we get that x is equal to negative 2, and we get that x is equal to positive 2. And then also, you could have used the quadratic formula. A value, C value, no B value. And really, like, you had 3 different options that you could use. So because our x-intercepts or our solutions were 2 and negative 2, our x-intercepts were negative 2, 0, and positive 2, 0. Okay, let's go ahead. Let's turn our page to the next section. So for this section, we're going to go ahead and we're going to work backwards. We're going to take each function and we're going to pinpoint some key pieces of information. So first off, if we look at h of x, we know that we see 1, 0 at 1, 2, 3, 4, 0. Remember, your 0 is where your parabola crosses the x-axis, where y is 0. And then our next 0 is 4, 5, 6, 7, 8, 0. Now, our axis of symmetry cuts that parabola in half. So it looks like it cuts it in half right here at this equation of the line. This is where x is 1, 2, 3, 4, 5, 6. So your equation is always an equation of a line, x equals 6. And then your vertex is always going to be that minimum point or maximum point. And for us, our minimum point is at 1, 2, 3, 4, which is negative because it's down. So our vertex is at positive 6, negative 4. So why don't you guys go ahead, pause this video, and then when you open it back up, we can go through it together. All right, so let's take a look. We have zeros here at negative 1, 2, 3. We have a 0 here at positive 3. We have a vertex or an axis of symmetry at the line where x is equal to 0. And our vertex is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, negative 9. Okay, now in our next problem, m of x, we have an x-intercept here at 0, 0. We have an x-intercept here at 1, 2, 3, 4, negative 4, 0. We have an axis of symmetry here where x is equal to negative 2. And we have a vertex at negative 2, 1, 2, 3, 4, negative 4. And hopefully your answers match mine. All right, so now we're given 2 functions. Based on the information given, let's answer some questions about that. First off, is this parabola concave up? Well, no, it's not actually because it's negative. So that would make this parabola concave down. Well, concave down parabolas look something like this. So in terms of your vertex, is your vertex going to be a maximum or a minimum? Well, it's going to be a maximum, and it is not going to be a minimum. Is our parabola compressed or stretched? Well, that would be from your A value. And even though our a value is -1, we're really only looking at the 1. That's pretty standard with the parent function. So it's actually compressed or not stretched. It's neither of those two. Now, what are the coordinates of the y-intercept? Well, if it's not in standard form, the y-intercept is just plugging in 0 for x and figuring out what your y value is. So we can do that over here. Y is equal to negative times 0 plus 4 times 0 minus 6. Y is equal to negative times positive 4 times negative 6. Y is equal to -1 times -24, which means a negative times a negative is a positive. So y is equal to 24. So therefore, your y-intercept is 0, 24. Our axis of symmetry is going to be taking the average of our two x-intercepts. Now, even though we don't have x-intercepts and we just have factors, we can definitely set each factor equal to 0. We can subtract 4 from both sides. We get that x is equal to -4, that's 1. And we have x minus 6 is equal to 0. We can add 6 to both sides. We get that x is equal to +6. Now you can take both of those values, -4 plus 6, you get +2. Take the average of that value, so divide it by 2, and we get 1. So our axis of symmetry is where x is equal to +1. Okay, let's take a look at example number 2. M of x is equal to 3 times the quantity x plus 2 times the quantity x minus 2. So first off, do we see a negative value for our a value anywhere? No. So yes, this parabola is going to be concave up, and no, it is not going to be concave down. Now, because our parabola is concave up, that means our vertex is going to be a minimum. And because our a value is 3, that means that our parabola is going to be stretched. Okay. Same thing again. Our axis of symmetry is taking the average of our two zeros. And 1, with that a value of 3, we really can't include it because we can't ever set 3 equal to 0, right? So we still just keep x plus 2 and x minus 2, and we set those equal to 0 because, like we said, we can't set 3 equal to 0. So x plus 2 is equal to 0. X minus 2 is equal to 0. We can subtract 2 from both sides. You get that x is equal to -2. Add 2 to both sides. You get that x is equal to +2. When you take -2 and you add 2, you get 0. 0 divided by 2 is still just 0. So our axis of symmetry is right through the origin where x is equal to 0. Now, what is the vertex? Well, we would take 0, plug it in for x. And when we do that, we still leave that 3 out in front. So 0 plus 2 times 0 minus 2. So y is equal to 3 times +2 times -2, which 2 and -2 make -4. -4 times 3 is -12. So our vertex is at 0, -12. Now, for the remaining time in class before you guys go ahead and start your homework, we just did a quick run through of everything pertaining to being given an equation in intercept form, like we did on this first page, being able to graph it, finding its x-intercepts, finding the axis of symmetry, finding the vertex, finding the y-intercept. We were able to take a look at the second page and make sure we really know the connection between having a positive or negative a value for your concavity, finding your solutions to an equation in factored form and seeing how they're graphed as x-intercepts. And then last but not least, we were able to work backwards with a parabola that's already given to us and label its zeros, label its axis of symmetry, and label its vertex. So now for the remaining time in class, I would really like you to go ahead and work through this very last page and piece this parabola all together now. You'll notice in Google Classroom that on the blank document, for today, day 2. There is also the document of the key. When you're done with this, go ahead and check your work before you move on to the homework for tonight. And I will see you guys tomorrow on Wednesday. Have an awesome night, everyone. Goodbye.